Welcome to Sec Math Academy. In this lesson, we are going to see F block elements, lanthanides and actinides. F block elements are also called as inner transition elements. Transition elements are D block elements. Okay. We are going to see memorization and electronic configuration of lanthanides. Memorization and electronic configuration of periodic elements are very essential to understand their properties, especially oxidation state, magnetic property, spectra, and so on. Earlier we have done for S, P, D block elements, and their video links I attached in the comment box. Okay, now we will go to the lanthanides and actinides. General electronic configuration for F block elements: N-2, F1 to 14, N-2, F1 to 14, N-1, D0 to 1, Ns2. Okay. Lanthanides are sixth period. Lanthanides are sixth period. N is 6. Actinides are seventh period. So for lanthanides, what will come? 5s2, 5f, 4f, 1 to 14, 5d, 0 to 1, and 6s2. Lanthanides are sixth period. So n is 6. So n-2 is 6 minus 2 is 4. 4f, 1 to 14. 5d, 0 to 1, and 6s2. For actinides, 5f, 1 to 14, 6d, 0 to 1, 7s2. Because lanthanides are in the sixth period, actinides are in seventh period, but both are in the third group. Okay? Note it down, this one. Okay. Look at the lanthanides elements: lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Okay, there are 15 elements, but lanthanum is not the F block element. Lanthanum is the D block elements. So from cerium to lutetium, that is from atomic number 58 to 71. So F block elements are 14 elements. Okay, 14 elements from 58 to 71. Just now we will memorize lanthanum and the 14 F block elements. Okay. First, lanthanum, cerium, praseodymium, neodymium, promethium, samarium. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium. Just memorize these 6 elements only: lanthanum, cerium, praseodymium, neodymium, promethium, samarium. Okay. Cerium, praseodymium, neodymium, promethium, samarium. You use any code words for you what is very easy to remember. LC, P, N, P, S. Okay. You can use any abbreviations for what is very easy to recall. Okay. LC, P, no, P, S. So lanthanum, cerium, praseodymium, neodymium, promethium, samarium, PM, SM. Okay. You may not get confused. Here P, here PM, SM, promethium, samarium. Okay. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium. These 5 elements plus lanthanum. If you memorize lanthanum, cerium, praseodymium, neodymium, promethium, PM, SM, PN, PS. Okay, praseodymium, neodymium, promethium, samarium. Starting element of F block element lanthanide is cerium. Okay, so lanthanum, cerium, praseodymium, neodymium, promethium, samarium. Try to memorize. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium. Okay. Then is we finished lanthanum plus 5. The next is europium, gadolinum, terbium, dysprosium. Europium, gadolinum, terbium, dysprosium. Europium, gadolinum, terbium, dysprosium. Okay, I have taken one universal name linking. Europe goods are terrific and dynamic. Okay, Europe goods are terrific and dynamic. TB is terrific and dynamic. Okay, so europium, gadolinum. After europium, gadolinum, because Europe goods are terrific and dynamic. Okay, terbium and dysprosium. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinum. Europe goods are terbium, dysprosium. Since Europe came, you recall Holland also. Holmium, erbium, Holland engineer. I have made simple things. Holmium engineer, holmium, erbium. Then thulium, ytterbium, lutetium. In actinides also last element is lawrencium. Okay, ends with L. In lanthanides also last elements ends with L. Last elements in lanthanides and actinides ends with L. So that is easy to remember. Lutetium. In actinides it is lawrencium. Okay. Europium, gadolinum, terbium, dysprosium we finished. After Europe goods are terrific and dynamic. Then what do you have to recall? Holland engineer. Holmium and Holland engineer. Okay. Then memorization of F block elements is very great. Then thank God. Thulium, ytterbium, lutetium. TYL. Thank you, Lord. Okay, understand? Lanthanum, cerium, praseodymium, neodymium, promethium, samarium. Europe goods are terrific and dynamic. Europium, gadolinum, terbium, dysprosium. Holland engineer. Stop it. Holmium, erbium. Thank you, Lord. Thulium, ytterbium, lutetium. Get it? Repeat one more time. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium. Europium, gadolinum, terbium, dysprosium. Holmium, erbium, thulium, ytterbium, lutetium. Okay? LCPNPS. LCPNPS. Then Europe goods are terrific and dynamic. Then Holland engineer. Europe, Holland. Then thank you, Lord. Very simple. Okay. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinum, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. LCPNPS, lanthanum, cerium, praseodymium, neodymium, promethium, samarium. Europe goods are terrific and dynamic. Europium, gadolinium, terbium, dysprosium. Holland engineer, holmium, erbium, thulium, ytterbium, lutetium. Thank you, Lord. Okay. We are going to see electronic configuration of lanthanides. Okay, what is the electronic configuration? N minus 2, 4F, 1 to 14, N minus 1, D, 0 to 1, NS2. Here N is what? 6. So, I put 6S2, 5D1, 4F0 for lanthanum. Lanthanum atomic number is 57. Xenon atomic number is 54. Okay, we are doing after xenon. Okay, xenon 54, 4F0, 5D1, 6S2, 5D1, 54 plus 1, 55, 55 plus 2, 57. Okay, then what I told, 4F1 to 14, 1 to 14. From cerium, it is 1, praseodymium 2. This is expected. Actually it's different. We are seeing only expected atomic electronic configuration. Cerium 4F1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Lutetium is 14. It is expected. All are 5D1, 6S2. Okay. Actually, as per the Afau principle, it has to enter 4F instead of 5D. Okay. But it enters 4F and 5D are what is same energy level. So it enters 5D. First electron enters to the 5D level. 5D1. Okay. So lanthanum electronic configuration is 4F0, 5D1, 6S2. It is a D block element. Okay. It is not a F block element because there is no electron. 4F0. Now we are coming to cerium. Okay. LC. We are coming to cerium. 4F1, 5D1, 6S2. One electron enters into the 4F orbital. Okay, good. Here expected and the actual is same. Expected and actual for lanthanum same. For lanthanum it is not totally F block elements. For cerium, expected and actual is same. Okay, 4F1, 5D1 and 6S2. Praseodymium, what is expected? 4F2, 5D1, 6S2. But it is not. 4F3. Actually, one electron has to go. So, 4F2, but D electron also jumping here. So, it is 4F3. So, what will happen D? It will be 0. 6S2. So praseodymium electronic configuration 4F3, 5D0, 6S2. Very simple. Okay. Because you see our electronic configuration, general electronic configuration N-1, D0 to 1. So 0 is also coming. Okay. Now neodymium, same 4F14, 4F4. This same set continues. 4F4, 5D0, 6S2. Promethium, 4F5, 5D0, 6S2. Samarium, 4F6, 5D0, 6S2. Europium, 4F7, 5D0, 6S2. Okay, good. Then gadolinium, what we are expecting, the trend has to continue. 4F7, 4F8, 5D0, 6S2, trend has to continue. No. Here it is not, the trend is not continuing. Here you see in the gadolinium, expected and the actual same. But the trend, praseodymium to europium what it has come, it is not continuing. When you go for walking on the park from left to right and then you are returning, when you are returning at the end, you will stay a little bit more. Okay. So the same way, 4f, there are 7 orbitals. Each orbital will have the 2 electrons. You are going from this to left to right, and at the end you are staying one more time because it is a stable one. Nobody wants unstable. Okay, at the end the people are staying more. Okay, 4f7. Okay, 5d1, 6s2. Then what we expect this trend 4f8 for terbium? No, it has not happened. So since we stay one end more, then we are we are recovering the speed. So 4f9, it becomes 4f9, and 5d, what will happen? Actually 8, 5d, this one. So 4f9, 5d will be 0 only, 6s2. Then the same trend continues. 4f10. For what? Dysprosium. 4f10, 5d0, 6s2. 4f10, 5d0, 4f holmium. Holmium is 4f11, 5d0, 6s2. Then erbium. 4f12, 5d0, 6s2. Then thulium. 4f13, 5d0, 6s2. Ytterbium. 4f14, 5d0, 6s2. Then lutetium. 4f15, not possible. F orbital have only 7 orbital, so it will have only maximum 14 electrons only. So 4f14, then 5d1, 6s2. Understand? Okay. Cerium 4f1, 5d1, 6s2. Praseodymium 4f3, 5d0, 6s2. Neodymium Pn, Ps 4f4, 5d0, 6s2. I am not going there. From here I am telling, because you have already studied lanthanum, cerium, praseodymium, neodymium, promethium. Promethium is what? Pm 4f5, 5d0, 6s2. After Pn, Ps, samarium, Sm, 4f6, 5d0, 6s2. Then Europe goods are terrific and dynamics. Europium, 4f7, 5d0, 6s2. Gadolinum. Gadolinum, what is the specialty? The expected and this are same. Gadolinum 4f7, 5d1, 6s2. Then terbium, dysprosium, 4f9, 5d0, 6s2 is terbium. Dysprosium 4f10, 5d0, 6s2. 4f11. Then after europium, what will come? Europe goods are terrific dynamic. Holmium. Holmium engineer. Holmium, erbium. Holmium is 4f11. Erbium is 4f12. Then thank you Lord. Thulium is 4f13, 5d0, 6s2. Ytterbium 4f14, 5d0, 6s2. Lutetium 4f14, 5d1, 6s2. Focus this one. Okay. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinum, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Lc, Pn, Ps. Europe goods are terrific and dynamic. Then what? Holland engineer. Then thank you Lord. Okay. Now, lanthanides, properties of lanthanides. Lanthanides are generally +3 oxidation state. Sometimes it will exhibit +2 and +4. When it will exhibit +2 and +4? If it is half filled or fully filled or empty filled. Now you see cerium is plus 4. It will exhibit. Why? Okay. Cerium is plus 4, it will exhibit. Why? 4 of 1, 4 of 1, 5d1, 6s2. If you take all these 4 electrons, it will be empty filled, 4 of 14. 4 of is empty filled, it will be stable. So cerium will exhibit plus 4. Okay. Then cerium will exhibit plus 4. Okay. Then praseodymium. Praseodymium, neodymium, I will come back to you later. This is also exhibiting plus 4 when it is forming oxides. Okay, we will now focus what is a stable one. Promethium, samarium, europium. Europium, you see, 4 of 7, 5d0, 6s2 only. These 2 electrons europium is plus 2. If you take 2 electrons out, it will be half filled. It is a stable one. Gadolinium is plus 3 only. Terbium. Terbium, 4 of 9 is there. From 9 you take 2. So it is 4 of 7. 4 of 7 is half filled. Half filled is stable. So that 2 and 6s2, it will exhibit plus 4. Okay. Then come to ytterbium. Ytterbium is plus 2. Why? 4 of 14, 6s2. If you take out, it is ytterbium plus 2. Got it? So, plus 3 all the elements. Plus 4 cerium. And then what is called terbium. You look at the electronic configuration, 4 of 9. Take 2 electron out. Okay, and 6s2. So, terbium. And 4 of europium, 4 of 7, 6s2 only. So europium plus 2. Ytterbium plus 2. Ytterbium plus 2 for fully filled. Europium plus 2 for half filled. Cerium plus 4 for empty. And terbium plus 4 for half filled. You understand? And one more property is, I just a little minimize, you can copy it. You can copy the electronic configurations and oxidation state. Copy down now. Thank you for watching. See you.